Here is case 1 of our integration by parts, and we'll look at the rule that governs this, and we'll look at some examples. We'll look at an example in this video and then another one in the video to come. Now here we are saying whenever, this is case 1 where you have a function with a polynomial term or an algebraic term. For example, you could have something with theta squared or whatever, or x squared or t. You know, these are some variables you could meet. Whenever you have something like that, just a variable, right? And it's multiplying whatever else. It could be multiplying an exponential function. It could be multiplying a trig function. When you have it like that, you always make u the algebraic term, okay? Except when you meet a logarithmic function. So here's an example. If I am to find the integral of x sine x with respect to x, here I know my u will be my x without even thinking. So the moment I see myself having the algebraic term, that is going to be my u, except there is a logarithmic function. For example, if it's x ln x. In this case, you do not make u equal to x, okay? No, you don't. U is not equal to x, but ln x is the one that is u, okay? Not the algebraic term, okay? So here, we would say automatically, we would say let u be equal to x. Well, if you remember, we said we will make it like this. This is what it would look like. This is what the integration would be. So we need a u and we need a v. And then this would be equal to uv, okay, the functions themselves, minus the integral of v du. Okay, so I hope you won't forget this. This is very important to remember. So what are we going to look for now? Now we will look for du dx, which is the derivative of u with respect to x. This, it's going to be 1. Okay, derivative of x is 1. So if I take this dx to the other side, it's going to multiply 1 and it will just be dx. So that means du is equal to dx. Don't forget this stage where you take dx to the other side. Now automatically I know that sine dv is sine x. Okay, I know that. And v would be the integral of sine x with respect to x, okay? I will integrate it to get v because I need v now. I have dv, I now need v. And that would be, v would therefore be equal to, if I integrate sine x, I get negative cos x, okay? So the integral of, it's like, what did I differentiate to get sine x? You know that if you are starting from cos going to sine, this you change the sign. So if I had differentiated cos x, I was going to get negative sine x. But here I got positive sine x, so I differentiated negative cos x. That is why. So the integral of sine x is negative cos x. All right, fine. Now with this, we can now bring it into our work. So therefore we can say the integral of x sine x with respect to x is equal to uv, and what is my u is x times v. What is my v? Negative cos x, minus the integral of v again, so it'll be negative cos x again, multiplying du, and what is du is just 1 dx or dx. Wow, really? So therefore this we can say the integral of x sine x, which is what we are looking for, with respect to x is therefore equal to x times negative cos x will be negative x cos x. Okay, then here this minus multiplies the negative cos x that was there, they become positive, right? So it's now plus the integral minus minus. This negative can go out there and it becomes minus minus, that's plus. Plus what? The integral of cos x with respect to x. So here we're about to finish. That means the integral of x sine x with respect to x is therefore equal to negative x cos x plus, what is the integral of cos x? That is sine x, okay, sine x. And then do not forget to add your constant of integration c now at the end. Okay, if you want to rewrite it, you could write as sine x minus x cos x. You can write it to say, therefore, integral of x sine x with respect to x is equal to sine x itself minus x cos x, okay, plus the constant of integration c. Wow, that's your final answer? Yeah, that's my final solution. All right, see you in the next video where we'll do another example.